Alright, so from our last video, we got that the equation for all of this information, and this isn't the full table, by the way. This is just a small portion of it that I copied over. But we found that the equation of all of this data is y is negative 3.789x plus 155.375. Now, it wants you to take this and put it into function notation. And it's relating bike weight to jump height. And in this case, the jump height was your y value, and the bike weight is your x value. Because x is always on the left-hand column, y is always on the right-hand column. And it works that way when you're graphing things on Excel as well. So we're looking at height versus weight. Okay, so instead of y, I'm going to have height with respect to weight is equal to negative 3.789 times the weight of the bike plus 155.375. Domain of this function. All right, so we had this graph. And it's going kind of like this. So eventually, it's going to bottom out somewhere over here. All of the x values that make sense are going to be between 0 and whatever this number is. And to solve for your x-intercept, which is what this is where it intercepts the x-axis, we plug in 0 for y up here. So we have 0 is equal to negative 3.789 times x plus 155.375. And I should probably write that out for you. 0, negative 3.789x plus 155.375. We're going to subtract 155.375 from each side. $785x, and now because we have a number times our x value, it's the same thing as having this, right? We're going to do the opposite to get rid of it. So I'm going to divide each side by negative 3.785. So that divided by negative 3.785, and that divided by negative 3.785. That means that x is going to equal about 41. And x, we said, is the weight. So our weight, W, has to be greater than 0. Remember with your signs, greater than, less than, is saying that W is bigger than. So the big sign is here, the small sign is here. W is bigger than 0, but it has to be smaller than 41. And that was measured in pounds. So, weight of the bike has to be between 0 and 41 pounds. Otherwise, it doesn't make any sense. It stops being functional at 41 pounds as far as being able to jump over the ramp. Range of the function is a lot easier. It's where it crosses the y-axis. And we know, since this is slope-intercept form, this is our slope, this is our y-intercept. So y is our height, h, and our height is going to be greater than 0 or equal to 0 inches. It's going to be less than or equal to 155.375 inches. Okay, that means that it's never going to go higher than 155 inches, and it's never going to go negative. It will never be a negative height. The slope of the line, is it positive or negative? The slope of the line we said is negative 3.789, and that is inches or pounds per inch, right? No, inches per pound. Negative 3.79 inches per pound, and it is negative. And the interpretation of the slope in words is that the bike will lose 3.789 inches for each added pound of weight. So every time that we increase the weight of the frame, every 1 pound will drop it about almost 4 inches, 3 3/4 inches. If the engineer designed the bike to weigh 18 pounds, predict the minimum jump height. Okay, so now our weight here is going to be 18. So we want H of 18 is negative 3.789, right? 785 times 18 plus, don't forget, we have this now, 155.375. So 3785 times 18 is 68.13. That's negative, so we're going to subtract that, or add that, to 155.375. We end up getting a positive 87.245 inches. Remember, this is inches, this is feet.